edge devices. So my dear friends, we do have a dynamic duo in the house, exactly the right people to take us through this. Please join me in welcoming our first speaker for this session. Give it up for Wei Tang. Thank you.
Hi everyone, this is Wei from Sony, and I'm responsible for the business development for AITRIOS. So today, actually, we have another topic which is going to be covered by my colleague Amir later. So before that, I would like to give you some background introduction about IMX500 and AITRIOS, because I don't think you may be very familiar with these two words at this moment. But after my introduction, I hope you can understand it better, that what we are doing and why we are here. So I think most people here, you may be familiar with the broader Sony group. So our company, Sony Semiconductor Solutions, is actually specializing in developing cutting-edge image sensors. So we actually develop these sensors that work on for mobile phone, automotive systems. So our technology is actually beyond the products you use or you see every day. So the fact is that Sony Semicon Solutions, we have the largest share of image sensor in this global market. So we shipped out about 1.2 billion image sensors every year. So by the way, if you look at the cameras of your mobile phone, half of them are made from our image sensors. So from various devices, we are trying to keep our commitment to innovation and to quality, which places us a leader in this industry of this rapid changing world. So Sony has democratized recreational photography for many years. Now we want to do the same thing for Vision AI. So by leveraging our advanced image sensor technology, we would like to empower a new generation of applications that can enhance everyday life, from smart devices to automotive systems. Let's look around the world we are living now. So people are talking about GPUs, crowd resource, whatever. So there are so many IoT devices that connect to the cloud. So we cannot imagine in every second, the amount of information, data, flow from the devices to the cloud, which is going to cause a data explosion eventually. So the word we are aiming to attach is that we would like to have an edge and cloud synergy. We would like to process the data to the edge device closest to the sensor itself. And by compressing the data we upload to cloud, we can contribute to reduce power consumption, and eventually we're going to contribute to the environment. So to contribute to build this an edge AI computing world, it redefines the role of image sensor from imaging to sensing. So Sony's approach to Vision AI starts at the very extreme, the sensor itself. So we designed and manufactured the world's first intelligent vision sensor, which we call IMX500, with on-chip AI processing capabilities. So this sensor, the output data, it's going to be not like the streaming images. It's going to be the metadata as we showcase here. So it's going to largely downsize data transmitted cost and help you to reduce the cost of the transmission to the cloud. And because of this output of metadata, it can also be very beneficial for very high privacy considerated scenarios, especially like human-related tasks. And it can also support high-speed, real-time on-chip processing with a flexible of AI module choosing and replacement from our platform. So this innovation actually transforms how the device they can perceive and interact with their environments. So this is a very short video actually showcasing the example of metadata that outputs directly from sensor. As you can see on the right-hand side, that's the information it outputs That's the information, like the use case, just care about. So, origin from this IMX500 sensor, we actually build up a lineup of devices. So these devices are very tiny, small cameras. It's just an example. So we have built these devices both in-house and with our partners. They are all equipped with on-chip AI processing capabilities, and they are ready to be purchased from our certificated channels, which you can check after our presentation. So far, I talk a lot about like hardware, what we do, but I know it's only halfway down to this vision edge AI development because there is software part. So we noticed that there are some common challenges, especially in edge AI development, due to people maybe lack of AI and machine learning insights. And also, if you want to deploy your AI module to the very tiny device, always there is limitation of like memory or whatever. When you want to deploy it, there are gonna be some accuracy drop during this process. And also, there is always variations in the scenarios of factors. You have to do further tuning work like every day. So to overcome these challenges, the solution from Sony is that we provide you an edge AI sensing platform. We call it ITRIOS. So you can use our pre-trained AI module from our platform, just one click, download and deploy. And also, it can support continuous retraining to your environment, and it's super user-friendly. So to conclude, our ITRIOS have two main components. One is hardware ecosystem. It's actually coming from the sensor I just introduced. We make it like a ready-to-use device as this ecosystem from in-house and collaborated with third parties as well. And also this Edge AI platform gonna give you a set of tools that you can develop, deploy, also manage your purely edge-to-edge vision AI solutions. So the platform itself is actually aiming at integrated and collaborated with our partner ecosystems. And we actually work a lot with our partners who are both want to contribute to this Edge AI vision world. So that's why we are here. So lastly, I would like to give you some like very simple examples of the use cases we already been working and deployed in the real world. So it's not limited to these industries. So it's actually showcasing that we can empower you, developers and enterprises, the capability to customize your own AI module with our software and hardware. So if you are interested, you can build up your own impactful solutions that's going to enhance the social implementation of Edge AI in our daily life. So I hope my introduction so far gave you a very basic understanding of our vision and ambitions to Edge AI vision world. So meanwhile, we did a lot in our internal team to make it happen. So I would like to hand over to my colleague Amir. So he's gonna give you a more detailed and intellectual approach that we are doing to optimize on-chip AI processing capabilities with our experience with YOLO models. So let's welcome Amir.
Thank you, Wei. Applause is for Wei, not for me. I appreciate for introducing us to Sony Semiconductors and the ITRIOS platform, as well as the IMX500. My name is Amir. I'm a product manager at Sony under Sony Semiconductors. I'm part of the group who develops the IMX500 Edge AI processor, as well as the AI development toolset for the IMX500. In recent years, I've devoted most of my career to enable deep learning on the edge, working with companies such as DesiAI and Sony Semiconductors. And in the next 10 minutes, we will dive into how we quadrupled our YOLO V8 Nano performance just by breaking the optimization paradigm. Okay, so I'll start the session by claiming that the YOLOs are edge-enabling models and are fairly easy to optimize. Thanks, Glenn and the team. And I will convince you on that, don't worry. We will then dive deeper into the optimization paradigm and how we got to a point where, where the post-processing prevents us from achieving our performance goal. And then we will show you how by unlocking on-chip NMS, we were able to break the post-processing glass ceiling and why we were able to achieve that. Lastly, you will see a real-life demo of running the model YOLO V8 Nano on our AI sensor with a Raspberry Pi 5. Okay, so I claimed that the YOLOs are edge-enabling models. So why is that? First, convolution blocks are the basis for the YOLO family, which makes them easier to optimize in terms of the fact that you usually don't lose much when going from float to 8-bit or even mixed precision. Other than that, the YOLOs are very well performing compared to their size to begin with. We call it value for money. But on the left side, you can see that even the smaller models are performing pretty well for their size. And due to the above, our experience is such that the Ultralytics models are built in a way that makes them easier to optimize for edge devices. Now let's talk about the naive optimization paradigm. Every deep learning practitioner will look on that graph that presents millions of operations per inference for the YOLO V8. Every deep learning practitioner will naturally focus on optimizing those operations that either appear the most or are consuming the most resources, for instance, in terms of latency. However, one needs to also pay attention that less frequent or less time-consuming operations are not overlooked. And as you can see, it's very easy to overlook the post-process here. And then they will become a system bottlenecks. You should look at the whole end-to-end system rather than only on the neural network. And here's an example. We took a YOLO V8 Nano, ran it on a Raspberry Pi 5 with the IMX500 AI sensor, and the post-processing running on the Raspberry Pi 5. Running on the host. These are the numbers we got. You can see 26 milliseconds for the neural network on the chip, 30 milliseconds for data transferring from chip to host, and post-processing almost 70 milliseconds. You can clearly see that the inference time isn't the dominant part of the latency. It is the data transferring, format conversion, and post-processing running on the host that takes more than 75% of the latency. And this is how the story of tail wagging the dog begins. You optimize by the book, you deploy to production, and the model runs perfect, but then the post-process gets you stuck. Now, if your edge AI processor was or is robust and flexible enough to run functions like the NMS or the post-process in general, then on the chip, then it can make dramatic improvements. And this is because of the reasons why post-processing on the host has its glass ceiling. And the reasons are the fact that, first of all, data transferring of large volume data consumes significant latency. In our case, here it's around 30 milliseconds. Also, handling format conversion and running the post-processing on an unoptimized hardware has its memory limitations and compute limitations. competing with all other resources. And this is unoptimal. In this case, it reached almost 70 milliseconds. Now, each post-process is different. And for example, pose estimation models outputs an even greater output. So it can take even more time to transfer and process. So we thought how we can do better. So I said that if your edge AI processor is robust and flexible enough to run operations such as the NMS, you're pretty much done. And this is the case. Running the post-process on chip solves both problems stated in the last slide. No data transferring as everything is done on chip, and running on an optimized hardware. Now, post-processes are different and various and changing with time. So hardwiring the post-process on the chip might help at times, but not all the times. The concept, the principle remains the same. So the IMX500 was designed with both efficiency and flexibility in mind. And so we could implement the NMS function within the AI processor. By the way, similarly, we could do the same with other post-processing tasks that can be implemented efficiently to run on the IMX500. And by doing so, we got a 4x acceleration with the same accuracy just by running the post-processing on the chip. 4 times faster inference. Okay, in this example, we can see the differences between running the post-process on the host, on the left side, and running the post-process on chip. To the folks who are watching online, you might see a slower FPS due to communication limitations, but I think it's pretty clear which side is better. I will say that our research and development is always on, so things are cooking as we speak, even with the Ultralytics team, as well as on-chip post-processing for both pose estimation and semantic segmentation for the YOLO V8, and hopefully sooner than later, YOLO V11. I will hand over back to Wei.
Yes, thank you, everyone. So I think we give you a background introduction and also some details. I think you may have lots of questions, but anything related, if we are running out of time, feel free to ask us, like partnership, like developer, packager, whatever events you can attending. We have lots of information we can share afterwards. So thank you.
Thank you. We do actually have a little bit of time for questions because we have a coffee break afterwards, coffee/drinks break. Yes, we're getting to that time of the day. Do we have any questions for Wei and Amir? That was a great presentation. I love that. Inference on the edge, really cutting edge, excuse the pun, cutting edge stuff right there. Or bleeding edge, as it says in your bio. We have a question straight away. We do indeed. Who? Yes, you have the cube, sir.
The ball guy again. My name is Henry from Open Systems. My question is for Amir. All you did, you say that all the process you made was done on YOLO V8. And my question was more related if you have tried on these new models like YOLO V10 where no maximum expression is needed. So maybe the post process is not necessary. That's what my question. Thank you.
Okay, so to my knowledge, we have customers that are running YOLO V10 on the IMX500. To be honest, we don't have any measurement for that specific model. We do have more models that we took their post-process into the chip. Specifically YOLO V10, I don't have numbers.
Okay, great question. And do feel free to continue the conversation. We have the QR codes there on the screen. Did you want to comment there? Or No, okay, we have any more? Is the cube being passed to somebody else? Any community questions? Any more questions? Yes, we do. Yes, my man at the back there, plugging in the community. Thank you.
So question came in, how many IMX500s can you connect to a single Raspberry Pi 5 before things start to slow down?
So to be honest, this is something that I cannot speak about until there's one, let's say, a official launch for the, I would say, for the product. I would say that the problem, if there is a problem, it's within the Raspberry Pi has only one socket, so it might be the bottleneck. But once the product is out, I believe we will all know what is the bottleneck, if at all.
All right, thank you. Great question. Watch this space. Do we have any more questions? IRL or virtually via the cube at the back of the room? I'm not seeing any hands up. If anybody is sticking their hands up and I've not seen it, just heard. Yes, we have a question. Thank you, sir. Could you introduce yourself to the room?
Hello, my name is Gary Jockert. I'm Glenn's brother. It's nice to be here with all of you. My question is, I had a question about the Raspberry Pi system that you were mentioning, and my question is whether it's a camera system, the Raspberry Pi, and if it is, how it works. Thanks.
Okay, so I'll try to wrap up things that were said between both sessions. So Sony produces the IMX500 sensor. I'm trying to figure out what I'm allowed to say or not. Okay, so we developed the AI sensor, let's call it for this matter AI camera. Now, Raspberry Pi is a different company that develops Raspberry Pi, and they will come out with a product that is infused with our edge AI processor, the IMX500. Does that answers your question?
Yeah, maybe just some comments from me. So actually in public, you may saw we have some like collaboration with Raspberry Pi already in public release. So please stay tuned. We have great products to be released very, very soon, which we may not be able to give you details here, but you will just check it, like scan the barcode, like everything here, please.
I like that. That's what you might call a teaser. Brilliant. Yeah, watch this space. And infused is a great word. I like that. That kind of can be interpreted a number of ways. That's brilliant. Yes, sir.
Hey, how's it going? Maybe kind of a naive question. I'm wondering, when the inference happens on the chip, is it like converted to RGB to the sensor format and then inference is done on that sensor format, or what's the kind of flow there?
Okay. Now, this is as much exercise as I get in a week.
Okay, so the IMX500 outputs both RGB output, so you can use it as a, I would call it stupid camera. But then it outputs also through another ISP, an AI inference metadata output. So you get both together. You get the stream of visual as you would get with any other camera. On top of that, you will get also the metadata on the video. You can split those, you can view them together, you can take only the metadata and send it to the cloud. But eventually, it's like in terms of the stupid camera, you get an RGB. Yeah.
Excellent question. Thank you, sir. We'll be talking quite soon. Do we have any more questions from the room? The next question might be, can I have a coffee/drink? And the answer will, of course, be yes. Okay, going once, no community questions, going twice. Okay, that was an absolutely fantastic session. You got the QR codes. Watch this space. I get the feeling there are exciting things coming. But first, please give it up for Wei Tang and Amir Servi. Thank you so much.